All right, if a circle has a radius of 65 meters, determine the arc length for each of the following central angles. All right, so here's 19 pi by 20, right? 20 pi by 20 would just be pi, right? 20 times pi divided by 20 would just be pi. And pi is like 180 degrees. So 19 pi by 20 is almost at 180 degrees. It's 19/20ths of it. So it's like 171 degrees, let's say. Now, if I measured this arc length, which is what we're trying to do. Now, if this were a unit circle, if this were just 1 meter, well then this would be exactly 19 pi divided by 20 meters. That's what radians are. If you have a radius of 1 meter, then the angle is actually equal to the length of that arc. But since this is 65 meters, well, this is much, much, much longer than 1 meter. And so this will also be much, much, much longer. As a matter of fact, it'll be 65 times that. And so the distance all the way around here is simply 65 times 19 pi by 20. Another way to look at it, guys, is if you have, let's say this were the angle were 180 degrees, right? Well, then the circumference around half of a circle, well, let's say the circumference around the whole circle would be pi times the diameter of 130. And so the circumference around half a circle would be half of that, pi times the radius of 65 meters. Right? Well, this is almost pi, 19/20ths of pi times the 65 meters. Right? Because this is 19/20ths of the way around to the halfway point, or the way to the halfway point, right? So if you multiply by 19/20 times pi, you're going to get this distance here. So the final answer is the arc length is exactly 65 times 19 pi over 20, or approximately 194 meters long. And that makes sense, right? If this is 65 meters right here, then this would be 65 right up to here at about 57 degrees. It'd be another 65, that's 130, another 65 or so, so that'd be like 195. It's just short of that, so yeah, that looks like it's about 194. All right, part B says an angle of 1.25. Well, just remember, radians are a bit trickier. It doesn't mean 1.25 degrees, which would be a really, really small angle. We remember that half of the way around is 3.14 approximately, or pi. And so this would be pi divided by 2, which is like, what, pi divided by 2 is like 1.57 is 90 degrees. 1.25 is shy of that, so like 71 degrees or so. And so this angle here, we're asking for the arc length. Well, the cool thing about radians is the arc length is exactly equal to the angle when this is 1 meter long. Since this is 65 meters long, well, the arc length is going to be 65 times the angle. So you just do 65 times 1.25, 81.25 exactly. So this is 81.25 meters. And if you look at this length right here, yeah, 65 meters. So if you eyeball it, 65 meters would bring you to about here. And yeah, that looks like about 81.25. So that feels good. Let's try part C. Ooh, now we're in degrees. All right, 150 is one of our special angles there. So what is the angle in radians? Well, we know that 30 degrees is pi by 6, right? So 60 is 2 pi by 6, 90 is 3 pi by 6, 120 is 4 pi by 6, and 150 is 5 pi by 6. So let's write 5 pi by 6, because radians are so much better here. And now A, the arc length, right here, if I were actually good at drawing, is equal to 5 pi by 6 times the radius. If the radius was 1, then the arc length would simply be 5 pi by 6. but it's 5 pi by 6 times the radius. And so A is approximately 170.17, and that's in meters, 170.17 meters. Let's check to see if that makes sense. If this is 65 meters, then this length is about the same at about 57 degrees. Another 57 degrees will give you another, that would give you 130, and it's a little bit more than that. Yeah, 170 seems reasonable. All right, given angle DCE, let's find that. There's DCE. All right, so it's this angle, right? This little angle in here is pi by 12. So pi to 12 is like 15 degrees. Pi by 12, because pi by 6 is 30 degrees, we know, so pi by 12 is half of that, pi about 15 degrees. And CE, right here, the length of CE, which is from here to here, this length is 4.5 centimeters. I can see that's already written in here, so that's 4.5 centimeters there. Determine the size of theta, right here, and x, which is right here. All right, let's get to work here. All right, the first thing I notice is this is a right triangle, and it's giving me already, this is 4 centimeters, and this is 8 centimeters. And so theta, I already know I have its opposite side and the hypotenuse. So theta is just the sine of theta, we know. Write that down. Sine of theta equals opposite 4 over hypotenuse 8, which equals 1/2. All right, so theta, I know, must be pi by 6. If you take the sine inverse of 1/2, you get pi by 6. All right, so that was an easy one. All right, now that I know this angle is pi by 6, and I know that this angle plus this angle plus this angle have to add up to pi, because 3 angles in a triangle add up to pi. You guys may remember it as 180 degrees, but in radians it's pi. So this is pi by 2, this is pi by 6, and we must be left with pi by 3. For anyone who's still uncomfortable with radians, remember this is a 90, pi by 6 is 30 degrees, and pi by 3 is 60 degrees. 90, 30, 60. That adds up to 180. So we know, I can write in, that this is pi by 3, and this is pi by 6. Well, whenever I have two lines that cross each other, like this, right, we know that opposite angles, right here and right here, must be the exact same angle. Also, this and this must be the exact same angle. So that means ACB, which is pi by 3, will be the same angle as DCF. So this whole angle is pi by 3. And if this angle right in here is pi by 12, well then this angle ECF must be pi by 3 minus pi by 12. Now, you could call pi by 3, if you want to get a common denominator, you could call this 4 pi by 12, right? Multiply top and bottom by 4. So 4 pi by 12 minus pi by 12 is equal to 3 pi by 12, otherwise known as pi by 4. 3 pi by 12 is pi by 4. For you degree people out there who still haven't made the conversions very well, this is pi by 4 is just a 45-degree angle. Pi by 12 is just a 15-degree angle. So that's a total of 60, and we know this is a 60, so that makes sense. And last but not least, now that we know that this is pi by 4, we know, we know that this one's also pi by 4. So that means this and this are both 4.5. And we can easily say that the sine of pi by 4 is equal to opposite over hypotenuse. So let's say the sine of pi by 4 is equal to, so the sine of that is always equal to opposite 4.5 over hypotenuse, which is x. Okay, then so let's we can get this x over here, cross it out from there. We can take the sine of pi by 4 and bring it down here. Divide both sides by sine of pi by 4. And so x is simply equal to 4.5 over sine of pi by 4, which should just be 4.5 times root 2. And since we already know that, sine of pi by 4 is 1 over root 2, that makes sense. So x is equal to 4.5 times the square root of 2, which is approximately 6.364. So that's your answer. 6.364 centimeters is approximately x, and theta is exactly pi by 6. If you want an exact answer for x, it's exactly 4.5 times the root of 2. Alright, on another video I've already done this problem, so just go check out my other video to find the answer to this problem. Let's go to number 12. Number 12. A wheel is rotating at an angular velocity of 1.2 pi radians per second, while a point on the circumference, right there, of the wheel travels 9.6 pi meters in 10 seconds. A. How many revolutions does the wheel make in 1 minute? B. What is the radius of the wheel? Alright, let's start with part A. How many revolutions does the wheel make in 1 minute? Well, we already know how many radians it travels per second. So in a minute, it's going to travel that many radians times 60. So 1.2 pi times 60 is 72 pi. Now that's how many radians it travels. Right? So the number of radians that it travels, well, I know that one rotation, one revolution is 2 pi. So if it's traveling 72 pi, well, every 2 pi is one rotation, so it must be 72 pi divided by 2 pi. That's the number of rotations, right? For every 2 pi, you have to divide it into like sections of 2 pi. That's another 2 pi. How many 2 pi's are there? And so 72 pi divided by 2 pi is 36. So we're doing 36 revolutions every minute. Alright, part B. What is the radius of the wheel? Alright, the radius of the wheel. Well, first of all, let's talk about what happens in 10 seconds. There are 9 points. So this point, this yellow point, moves 9.6 pi meters in 10 seconds. Well, let's see how many radians it moves in 10 seconds. Radians is the angle, and we know it goes 1.2 pi radians every second. That's the angular velocity. So every 10 seconds, it must go 12 pi, right? This multiplied by 10. So if this is every second, then in 10 seconds, it goes 12 pi. Okay, so now keep in mind, 12 pi is actually the angle, right, in radians that it moves around every 10 seconds. But we also know that if the radius is exactly 1, if this dot is exactly 1 from the center, well, then the distance will also be the number of radians. So it will actually travel at 12 pi meters. That's only if this arm is length 1. If the arm is shorter than 1, or if the dot is at a spot that's closer than 1 meter away from the center, then it's going to go less distance. And if the dot is farther away, it'll go more distance. Okay, as an example, let's say the dot only goes 6 pi around. That's half the distance. So that means that it must not have a radius of 1. It must have a radius of only 1/2. Right? So 6 pi divided by 12 pi. If it were 24 pi that it would go, that means it must be twice as far out. So it has a radius of 2 meters instead of 1 meter. That would be like saying 24 pi divided by 12 pi. So basically, however far that this dot goes around the circle compared to the 12 pi is what the radius must be. Right? So if it just went 12 pi around, that means the radius is 1. If it goes 6 pi around, then the radius of where that circle is must be 6 pi over 12 pi, or 1/2. If it's 24 meters around, the full circle, or in that amount of time, then that means it's 24 pi over 12 pi, which means 2. The radius must be 2. And in this case, it's 9.6 pi meters in 10 seconds instead of 12 pi meters in 10 seconds. So it must be 9.6 pi divided by 12 pi must be the radius. And 9.6 pi divided by 12 pi is equal to 0.8. Therefore, the radius of this circle must be 0.8 meters. Alright, two pieces of mud are stuck to the spoke of a bicycle wheel. Piece A is closer to the circumference of the tire, and piece B is closer to the center of the wheel. Is the angular velocity at which piece A is traveling greater than, less than, or equal to the angular velocity at which piece B is traveling? So the angular velocity is the amount that it's rotating. So like how many rounds per minute, right? Or the angular velocity is like how many radians, you can say, per minute. And they're both turning at the same pace. They're both doing one revolution at the same amount in the same amount of time. So is the angular velocity less than, equal than, or greater than? It is equal. They're both equal. Is the velocity at which A is traveling greater than, less than, or equal to the velocity of B? Well, since A is on the outside, imagine running around a track in the outside lane or on the inside lane. You're going to do less distance if you're on the inside. So B is doing less distance. So the velocity at which A is traveling is greater than the velocity that B is traveling. That's the actual velocity, so distance covered. Angular velocity is different. The angular velocity is what angle it is. So this one, they're both going 2 pi in the same amount of time, or 360 degrees in the same amount of time. All right, but for B, A is actually traveling faster because it's covering a greater distance around. If the angular velocity of the bicycle wheel increased, all right, let's increase the velocity here. Let's double it. Okay. Now the question is, would the velocity at which A is traveling as a percentage of the velocity at which B is traveling increase, decrease, or stay the same? Okay, so I know that if something's on the outside, let's say there's a radius of 1 here. Well, then something on the outside of this will be traveling at exactly the same rate as the angular velocity, right? The angular velocity in radians is the exact distance that something will be traveled if it's 1 meter out. And I know something that's half a meter out will exactly be half of that. So no matter what the speed is, the one that's halfway there will be covering half of the distance. So if the angular velocity of the bicycle increased, would the velocity at which piece A is traveling as a percentage change? No. Something that's 50% of the way out will cover 50% of the distance. So the answer is no. Will it increase, decrease, or stay the same? It'll stay the same as a percentage. In your notebook, sketch the graph shown and label each angle in degrees for 1 revolution. Then express each of these angles in exact radian measures. All right, I can do that. All right, so this one is, we already have 30, 45, 60, 90. There's going to be another 30, so 120 degrees. I know down here is 180 degrees. I know this line right here is halfway between 90 and 180, so it's going to be 135 degrees. Let's see, this is 30 short of 180, so 150 degrees. This is 30 degrees more, 210 degrees. Let's go down to the bottom here, 270 degrees. It's 180 plus another 90. And then halfway between 180 and 270 is, say, add 45, so 225 degrees. And halfway between 270 and 360 is going to be 315 degrees. Okay, let's see this one. Just short of 270 by 30 degrees, this is 30 degrees here, is 240 degrees. And long by, like beyond 270 by 30 is 300 degrees. And just 30 degrees short of 360 is 330 degrees. All right, exact radian measures. Well, start 0 degrees is just 0 radians. And 360 degrees is 2 pi radians. One full revolution is 2 pi radians. All right, so half a revolution is pi. I'm going to put that over here. Half of that at 90 degrees is pi divided by 2. I could call it pi by 2. Half of that, so at 45 degrees, is pi divided by 4. So pi by 4. So let's just do all the multiples of 45. So this is pi by 4. And there's going to be 2 pi by 4, which is pi by 2. This is going to be 3 pi by 4 every 45 degrees. 180 is 4 pi by 4, but 4 pi by 4 is just pi. 225 is 5 pi by 4. 270 is 6 pi by 4. Well, 6 pi by 4. Well, we'll do that one later. 315 is 7 pi by 4, and finally 360 is 8 pi by 4. 8 pi by 4 is just the same as saying 2 pi, which we already had right there. All right, so now let's do the 30 degree angles. So 30 degrees is 1/6 of 180 degrees. So since 180 degrees is pi, this is going to be pi divided by 6, which means 60 is 2 pi divided by 6, or reduced is pi divided by 3, because it's 180 divided by 3. 180 degrees divided by 3 is 60 degrees. Let's erase this little arrow. All right, the next one. So 30 degrees is pi by 6, 60 degrees is 2 pi by 6, 90 is 3 pi by 6, 120 is 4 pi by 6, or we could call it 2 pi by 3. 4/6 reduced is 2/3. 150 degrees is 5 pi by 6. Right. 180 is 6 pi by 6. 210 is 7 pi by 6. 240 is 8 pi by 6. 8 pi by 6 can be reduced. Every 60 I should be reducing it to thirds instead of 6. So this is 4 pi by 3. Alright, 270 is 9 pi by 6, or we could reduce that as 3 pi by 2 if you divide top and bottom by 3. And that's also like, since 90 degrees is pi by 2, that means 180 is 2 pi by 2, and 270 is 3 pi by 2. Alright, so that's how many, let's see, for 30 degrees, we're pi by 6, 2 pi by 6, 3, 4, 5, 6, 7, 8, 9. Now we're at 10 pi by 6 here. Or better yet, 5 pi by 3. 11 pi by 6 right here. 11 pi by 6. And I think we have them all. And 12 pi by 6 is the same as 2 pi. There, we've got them all. Now keep in mind these radian measures, that's just another way of measuring the angle around. And so instead of 270 degrees, you can just use 3 pi by 2. Just make sure your calculator is in radians when you're using 3 pi by 2. Also, if you happen to have a radius of 1, well then the circumference, like that arc length, right up to here is pi by 3. Right up to here is pi by 2. Right up to here is 2 pi by 3. So the arc length is also equal to the angle when you have a radius of 1. If the radius grows and becomes 2, well then it'll just be whatever that angle is times 2. If it grows to become 3, it'll be whatever that angle is times 3. So it's quite convenient that way.